In this problem, we want to find the integral from 2 to 5 of the quantity of 2x minus 1 dx. In other words, we're finding the antiderivative. We're looking for what we took the derivative of to get this 2x minus 1. When you're dealing with something like this, whenever you're adding or subtracting inside of an integral, it's just like adding and subtracting when you're taking a derivative. You can just take each of them separately. So let's start with the antiderivative of 2x. This is just a standard polynomial. So all we have to do is take this 2x, and remember, when you perform a derivative, you multiply the power out front and then subtract 1 from it. Well, when you perform an antiderivative, you take the power, which in this case is x to the first, and you add 1 to it. And then you divide by that new power. So we're doing the exact opposite of a derivative. From here, we have the antiderivative of minus 1. Well, think about what we had to take the derivative of to get this minus 1. Whenever you just have a constant inside of your integral, then the only thing that could have gotten you to that constant was if there was an x attached to it, because the derivative of negative 1x, the x goes away, leaving you with that negative 1. So we just attach an x to it, and we have performed our antiderivative. And once we do all of this, we have now performed the antiderivative, so we put a line here, and we put our limits of integration next to it, because the integral symbol and the dx go away, but we are still left with the limits of integration to evaluate, which are the 2 and 5. So we say 2 goes on the bottom, 5 goes on top, just like they were in the integral. And now we can just start evaluating. We'll start by simplifying. We have 2x squared over 2 minus x from 2 to 5, which simplifies down to x squared minus x from 2 to 5. And now to evaluate the limits of integration, the way that we do this is we take the top number and plug it in for every single x. Then we subtract when we plug in the bottom number. So this is going to be x squared, or 5 squared, minus x, which is 5, minus the quantity of x squared again, but we're plugging in 2 instead of 5, so 2 squared, minus x, which is again 2 in this case. So simplifying this, we get 25 minus 5 minus the quantity of 2 squared is 4 minus 2, which leaves us with 25 minus 5 minus 4 minus 2 is just 2, giving us 25 minus 5 is 20, minus 2 is 18. So the integral from 2 to 5 of 2x minus 1 dx is just 18. One more thing that I'd like to note here is when you do an antiderivative or an integral, typically you have a plus c attached at the end. But whenever you do what we call a definite integral, these are definite integrals when they have these numbers, these limits of integration, the plus c is removed. It's removed in this step. When you subtract, when you plug in 5, and when you plug in 2, technically there would have been a plus c here, and then a plus c in here, and they would have canceled each other out. That's why we don't even need to include them. They just aren't even written in the problem. Only when you're doing an indefinite integral where there are no limits of integration do you need that plus c there.